All right, you geometry gurus, this is Mr. Moss coming at you again on another wonderful day of distance learning. We now have section 3.2 to go over, and I will be loading these up tomorrow, which will be Friday. And then assignment will be there as well, and then you'll have a quiz to take that'll be due by the beginning of next week. So look for that as well. for that. Okay, so today we're talking about what are called translations. And we'll talk about the definition here. We'll read it, and then I will put it in my terms. Hopefully that make it a little bit easier for you to understand. It says a translation is a function that maps each point to its image along a vector. See, that's probably a new word that we haven't used yet, called the translation vector, such that, and here's the rules, each segment joining a point and its image has the same length and as the vector, and this segment is also parallel to the vector. So here's a scenario. So when we're talking about a vector, anything that shows with an arrow and what direction it's going in, and this is going to be used a lot in physics. If you ever take a physics class, we use vectors all the time to signify what direction items are going or how gravity reacts to certain objects and stuff like that too. So again, nothing new that we have. Here's our original thing, which is an A, and then we move it to a certain point and it's A prime again, okay? And this is how a vector looks. Now it's when we talk about vector K, they're dealing with this, and then they got like a little arrow, but only half of an arrow right above it. Okay, so the point is the translation of this along the translation vector of K. Okay, so what I'm going to say is all we're going to do is I were to take a piece of paper or like my 3i5 card that I had from the previous lesson, and all I'm going to do is just, here's my original spot, and all I do is I'm just going to move it and slide it to another position without turning it, twisting it, rotating it, all this kind of stuff. We're not going to do any of that kind of stuff, or we won't even be flipping it either and making it all that way too. All we're doing is just taking it and sliding it from one spot to another, and then we're done. Okay, pretty simple. So with that being said, here's what we're going to do. And looking at our first examples down here, and I'm going to have you practice as well. Some point you can pause the video and work on it. So copy the figure and the given translation vector, then draw the transition of the figure along the translation vector. So basically what it's saying is at this distance right here, all we want to do is just move in that same direction. So if I were to do that, sometimes they give you a distance, sometimes they don't. It looks like they didn't do it on this one. Okay, so all we're going to do is basically, here's our vector W, and if we want to, we're just going to draw each one of the lines as if it were to be parallel to this one, and all we would do is kind of go this way, right? I'm not doing a very good job. I probably have a thing out there that, I'm not drawing a very good scenario here. Anyway, so then you would sit there and have J, G, H, and I, so we'll just go call this G prime, H prime, and it would be a certain distance what they would give you, but they're not really giving you a super distance here. This is J prime and A prime. So this right here is what I really want to do. So you would measure that out, and then all we would do is connect the points. Okay, and I hope I did a decent job of what it looked like. Oh, not too bad. Okay, so now what I want you to do is go ahead and do the same thing. Pause the video for a few minutes, practice on your own, and this way we want to make it so it goes in the same direction. So that means we're going to go down this way. So pause, and I'll see you in a few minutes. Okay, hopefully you tried on your own. I'm going to show you what's going on here. So again, we want to go A, we're going to go this direction, so we're going to go A, C, and it looks like B might be here. So here's our B prime, A prime, and our C prime. And all we would do is just connect our points here, okay? And that would be our answer. Now, what we're going to do is we're going to get into more of the scenario where we want to deal with numbers, like with coordinate points, and that's what our next part is going to be about. All right, let's go ahead and move down to that part. So let's go ahead and go to the bottom of this page. Here we're talking about translation in a coordinate plane. This is where we're going to be concentrating mostly. So here's our original point, okay? And we're going to translate it by either adding, or in this case, sometimes we'll be subtracting a number to the x coordinate, and also adding or subtracting something to the b coordinate. Therefore, it would change it. So here we go. So here's our situation where we have our original point P, and we're going to go to P prime over here. Okay, and our original point is negative 2, 3, as it shows here. Now it says we have a vector. Now notice the reason for a vector here is, look at the parentheses on this. They're almost kind of like less than and greater than signs. So that tells us that that's how we're going to move it. So that basically what's telling us is that we're going to put, this is going to be our A, and that's going to be our B. So that means we're going to put a 7 in here, and we're going to put a 4 in here. And then we're going to add or subtract it to the original P in here, which would have been negative 2 and 3 over here, as it shows up here in this example right here, what we get. And then our new coordinate point is going to be 5, 7. So pretty simple on that part. Okay, I like these better than the ones up there without having to use a ruler. All right, let's move on to the next page. We're on page 6 of our guided notes. We're going to do the exact same thing here. And we're going to have you, I'm going to give a couple examples, and then I'm going to have you practice as well. So here's our scenario. We want to graph triangle TUV with vertices, and that's what we have already. And then we want to use a vector of negative 3 and 2. So what I like to do is I'd like to graph it first and then give the coordinate points, because that's what they're going to ask you to do. So what we're going to do here is I'm going to start at U. And it's going to tell me I'm going to go 3 units to the left, and then I'm going to go up 2 units. That's all we have to do. So here we go. So from U, we're going to go 1, 2, 3 to the left, and then up 2. And I put my point, which would be U prime. Okay. Same thing, we're going to do the same thing with V. We're going to, again, go the same distance, 3 to the left and up 2. 1, 2, 3, up 2. That will be my V prime. And then we'll do the same thing with T. Over 3, 1, 2, 3, and up 2, and that would be my T prime. And then all we have to do is just connect our points. I'm not going to do a very good job here, so don't laugh at me too much. Okay, and then we get our translation. And then what we could do as far as the translation, what I'd like to do too is now we take the coordinates of each one of these. So we're going to go 1, 2, 3, 4, and down 2. So we're going to go call this negative 4, comma, negative 2. Okay, this one's going to be 1, 2, 3. So we'll go 3, and then we're going up how many units? 1, 2, 3, 4. So that's our new units for that one. And then the same thing here, we're going to go 1, 2. So that's going to be positive 2. And then we went down 1, 2, 3. That's where I was saying where the negative was coming from. So we have 2, negative 3. And there's our answer. Okay. All right, let's go ahead and look at the second example where now we have to do actually 2 of them. So I'll get my red pen out here and we'll do this together. So we're going to create a pentagon. Let's do it in green first. Okay, so let's do our points here. So we've got 1, 0. So we've got 1, 0. So we'll call this P. E is 2, 2. 1, 2, 1, 2. So we'll call this E. We've got 4, 1. 1, 2, 3, 4, 1. This is our N, and then we got our T, which is 4, negative 1. 1, 2, 3, 4, negative 1, and that is T. And then we have A, which is 2, 1, 2, and then down 2, which is going to be A. So here is our pentagon. Not going to be exact kind of pentagon, but it gives us 5 sides, and that's all we need. Now, here's what we want to look at, our vector. How are we going to translate that? And we're going to do it that way there, okay? So that means we're going to go 5 units to the left, and then we're going to go down 1 from each one of these points. So let's go ahead and start with A. Since it's the lowest point, we're going to go left 1, 2, 3, 4, 5, and then down 1, we're going to call this A prime. I'm going to go counterclockwise or clockwise. So let's do the same thing here. So we can go 1, 2, 3, 4, 5, and then down 1. And we'll call that P prime. Again, 1, 2, 3, 4, 5, down 1. We'll call it E prime. N, 1, 2, 3, 4, 5, down 1. Call that N prime. And then T is our last one, which is 1, 2, 3, 4, 5, and down 1. We'll call it T prime. Okay? And then we can go ahead and connect our dots, and it should look the exact same thing. We just shifted it. Now we identify our coordinates, which would be what? 1, 2, 3, 1, 2, 3. So we got -3, comma -3. This one's going to be 1, 2, 3, 4, -4, comma -1. Is that right? Yep. Okay. And then the other one here is 1, 2, 3. So we're going to go -3, comma 1. Okay. And then N is going to be -1, comma 0. And then T is our last one, which would be -1, comma -2. Now, there's one other way we could get the coordinates of this 1 and 2 on each one of these up here. If I wanted to, I could take like P. I'm going to go 1, comma 0. Okay. And I'll take the thing underneath it and I'll go -5, comma -1. And I'm going to add those up. Okay, because that's what the rule said that we did in the beginning. So 5 plus negative, say 1 plus -5 is going to give me a -4. And then 0 plus a -1 is going to give me a -1. And that is my new coordinate for our P prime. So let's double check it over here. -4, -1 is correct. Excuse me, we can go through all the same thing. I'll do one more for you in this case. All right, so let's go to E, and we'll take 2, comma 2, and we'll take the same one again, -5, -1. And we'll add them up again. So 5 plus, that gives me a -3. This gives me a +1. And this is our E prime. So let's look at E here. See, here we go, -3, 1, and then we got a match. All right. Okay, so it's your turn. And what I want you to do is do it on your own, and you can turn off the video for a few minutes right now and practice it on your own, and you can come back and look at your results from what I did here. Okay? All right. Hopefully you got a chance to do that on your own. So let's check it out. Let's do this in green again. So we got triangle ABC. We got -3. 1, 2, 3, -2. Whoops, that's our A. See, I'm writing coordinates already. B is 4, 4. 1, 2, 3, 4. 1, 2, 3, 4. That's our B. And we're going to go 3. 1, 2, 3. Down 3. 3, and that's my C. Now it says our shift is going to be -1, 3. So what we're basically going to do, we're going to go left 1 and then up 3. So we're going to kind of have to guesstimate on this B one up here. So we go left 1, up 3, 1, 2, 3. That would be my B prime. Again, C is left 1, up 3. C prime, and then again left 1, up 3. That'd be my A prime, and then we got our answers. And then we draw our lines. And we identify our coordinates, which would be, remember, we could just add up here, so that would give us what, -4, comma, +1, right? This would give us what, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So it would be 3, comma 7 if we did it correctly. And then we got, this one is at 2, comma 0. Oops. Okay. All right, we're going to come back onto the part 2 of this video and show you the second example on this as far as its results.